Hello, my dear ones. If you're reading these lines right now, it means we're together again, and that is always something special for me. Imagine us sitting side by side somewhere quiet, maybe with a cup of tea or coffee, talking not about daily rush or headlines, but about something truly vast. Today, I want to invite you on a journey, a distant one, a deep one. Almost philosophical. We're going to Mars, but not the Mars you see in NASA photos. We're going to the Mars it was billions of years ago. Because once upon a time, Mars was a completely different world. And every time I read about this, I feel something strange inside, as if we're talking not about a planet, but about a life story that could have turned out very differently. Billions of years ago, Mars was not a cold, lifeless desert. Scientists have discovered dried riverbeds, deltas, branching channels, traces of ancient lakes, and possibly even entire seas on its surface. These formations cannot be explained by chance. They look far too similar to landscapes on Earth, shaped by flowing water. This means that water truly flowed across the surface of Mars for a long time, steadily, and in large volumes. And where there is liquid water, there is hope. Because water is not just a chemical compound, it is the foundation of life, a catalyst for processes without which complex systems cannot emerge. In those ancient times, Mars had a much denser atmosphere. It trapped heat, protected the surface, and created conditions where the climate was far gentler than it is today. Some regions may have resembled Earth's tropics: regular rainfall, stable temperatures, and an active water cycle. Imagine Martian plains crossed by rivers, clouds forming in the sky, and seasons that were not nearly as harsh as they are now. When I think about this, a cinematic image appears in my mind. Mars was not yet the red planet. It was a planet of water, sky, and movement, and that realization makes its present state feel even more tragic, because then began a slow, almost imperceptible turning point. Mars did not die suddenly. It faded, step by step. One of the key moments was the loss of its magnetic field. A magnetic field is an invisible shield for a planet. We rarely think about it, but it is what protects an atmosphere from the solar wind, a stream of charged particles constantly emitted by the sun. Earth has this shield which suits your mind, so B and me and D, which is why our atmosphere has survived for billions of years. Mars once had one too, but over time it weakened and nearly vanished. Once the magnetic field faded, Mars became defenseless. The solar wind began to literally strip the planet's atmosphere away into space, not in a single blow, but slowly, molecule by molecule. Atmospheric pressure dropped, the air grew thinner, and the climate became increasingly extreme. According to data from the NASA MAVEN mission, over hundreds of millions of years, Mars lost most of its water. Some of it was broken apart by solar radiation, allowing lightweight hydrogen to escape into space. Another portion froze. First into polar ice caps and later beneath the surface. This ice still exists today, like a preserved memory of the past, frozen in time. At a certain point, surface pressure fell so low that liquid water could no longer exist. Even if ice briefly melted, the water would instantly evaporate or freeze again. Mars crossed a critical threshold, a point of no return, but that isn't the whole story. There is another important factor: the planet's size. Mars is smaller than Earth, which means it cooled internally much faster. Its core gradually lost heat, tectonic activity weakened, and volcanoes fell silent one by one. Yet volcanoes play a crucial role in sustaining an atmosphere, releasing gases, renewing its composition, and helping maintain pressure and climate balance. When volcanic activity ceased, Mars's atmosphere stopped being replenished. The planet seemed to lose its heart. Its internal engine shut down, and without a magnetic field, without volcanoes, without a dense atmosphere, Mars began to freeze completely. Slowly but inevitably, it transformed into a cold desert. Rivers dried up, lakes vanished, water retreated underground or escaped into space. The surface became what we see today, harsh, silent, and almost motionless. Modern Mars is a world with an extremely thin atmosphere, low pressure, and extreme temperatures. A world where water exists only as ice and dust. A world that appears dead. And yet, it is this very world that preserves traces of a far more life-friendly past. And here comes the most thrilling part. The most important question science still cannot answer definitively. Did life manage to arise on Mars before the planet finally lost its tropics? If conditions truly resembled those on Earth, if water flowed for millions of years, if the atmosphere was stable, then life had a chance. Perhaps it was only simple microorganisms, perhaps something incredibly fragile and short-lived, but even the possibility of life changes everything. Every new rover, every drill, every soil analysis is an attempt to listen to the planet's past. It's as if we keep asking Mars the same question over and over again. Were you alive? And it answers not with words, but with landforms, chemical traces, and frozen structures. And you know, for me, this story feels deeply personal. Mars is not only about space, it's about us, about the fragility of worlds, about how easily balance can be lost, about the fact that even a planet can lose its future when its protection and inner fire disappear. If this story made you think, if it stirred a quiet feeling inside, sadness, awe, or wonder, then we felt the same thing together. Thank you for taking this journey with me. Thank you for being here, for listening, for feeling. Take care of yourselves, take care of Earth, and never stop asking the universe questions. Until our next meeting, my dear ones, I'm always happy you're here.